Here we are on page 9 of quadratics. Number 8. For each of the following quadratics, find the axis of symmetry, the intercepts, that would mean the x-intercepts and the y-intercepts, the coordinates of the vertex, and sketch. Okay, so let's look at A. Axis of symmetry we're going to find with the equation negative b over 2a. So we're going to look at the a value, which is 1, the b value, which is negative 2, and the c value, which is c. And we're going to find the axis of symmetry. So negative b would be negative of negative 2 all over 2 times 1, which is the a value. So actually that's 2 over 2, which is 1. So the axis of symmetry is just x equals 1. To find the coordinates of the vertex. So the vertex, we already found the axis of symmetry value, and once we find that, we can use that to find the vertex. Actually, it's already half the vertex, right? Because the vertex is the x value of the axis of symmetry, and then it's the y value that corresponds to that. How do we find the y value that corresponds to this x value? We simply use the equation x squared minus 2x plus 5, and we plug in the value 1 for x. And that is going to give us the value of y, which corresponds to that x, which is the y value of the vertex. So that would be 1 minus 2, negative 1, plus 5, which is 4. So the vertex here is going to be 1, 4. Find the axes intercepts if they exist. Axes intercepts are actually kind of easy to find. To find the y-intercept, the y-intercept always has an x-coordinate of 0. So if I put 0 into the equation, like y equals 0 squared minus 0 plus 5, that gives me the y-intercept. The y-intercept is going to be 0, 5. The x-intercepts, on the other hand, are going to be equal to the roots of the equation. So how can we find the roots of the equation? Maybe the question we should ask first are there real roots for this equation? We can do a really quick check, which is to find the discriminant. B squared minus 4ac, remember? So b squared is going to be negative 2 squared minus 4 times a times c. So that's going to be 4 minus 20, which gives us a negative 20. Negative discriminant, that means that there are no x-intercepts. So there are no x-intercepts. Okay. So if there's no x-intercept, that kind of makes finding the factors irrelevant. Okay, so let's try to graph this now in this little square here. So I'm going to plot the vertex, which is 1, 4, and I'm going to plot the y-intercept, which is 0, 5, and so if I know that this is the then I know that the axis symmetry is at 1, and I can already even start graphing other points because it's a standard sized parabola. I can tell because it went over 1 and up 1, right? So there's my A, okay? And now let's move on to C. Let's see. So we have this one here, it's 2x squared minus 5x plus 2. Let's start with the axis of symmetry. The axis of symmetry is going to be it's going to be x equals negative b, which is going to be negative 5, which is 5, all over 2a, which is going to be 2 times 2, which is 4. So we have x equals 5/4. That's the x coordinate of the vertex also. So how do we find the y coordinate of the vertex? So we're going to put 5/4 in this equation. So it's going to be 2 times 5/4 squared minus 5 times 5/4 plus 2. Okay, let's bring some bad memories of elementary school back. So we're going to do some fraction manipulation here. We put in 5/4 in for x here and here. We square the top, we get 25. We square the bottom, we get 16. 25 times 2 divided by 16 is also equal to 25/8. Okay. 5/4 times 5 is 25/4, which we can also write as 58. Plus 2. And so we're going to combine 25/8 minus 58. That's going to give us negative 25/8. 2 is the same thing as 16/8. When we combine these two with addition, we're going to get negative 9/8. So all that work just to figure out that the the coordinate of the vertex is negative 9/8. So now we know that the vertex coordinate is going to be 5/4 and negative 9/8. Okay. And then we would also like to know the axes intercepts. Let's see. So what would be the y-intercept? That's the easiest one to find, right? So to find the y-intercept, we're just going to plug in 0 in for x. So we're going to get y equals 0 plus 0 plus 2. So the y-intercept is actually equal to 2. How do you find the x-intercept? Well, we find the x-intercepts by finding the roots. And let's see, I'm going to use the calculator maybe to find the roots this time. Remember, to get here to find the roots, we do apps, polysmlt, hit enter. We go to polyroot finder, which is option 1, second order, next, and then we're going to put in the coefficients 2, negative 5, and 2. So 2, negative 5, negative 5. And 2. And then we solve. Oh, okay, it didn't look too bad, does it? So the x-intercepts are 1/2 and 2. X-intercepts are 1/2 and 2. Okay, and the y-intercept is 2. So let's try to sketch that. I'm gonna divide this up in a different way. Kind of zoom in because these points are very small. So let's see. I'm going to divide this into like that. Okay, and so these are the units. I'm going to make it a really big graph. And so the vertex is at 5/4, which is about here, and negative 9/8, which would be negative 9/8 would be here. So the vertex is here, and then I'm going to find the y-intercept at 2, so the y-intercept is here, and the x-intercepts are at 2 and 1/2, so it would be here and here. Now let's connect those and make a parabola out of them. Okay, something like that. All right, and remember that the axis of symmetry was x equals 5/4, and that is at x equals 5/4. So our drawing is pretty good. I just made some space for myself here. So here for E, we have the coefficients -3, +4, and -1. Let's find the x or the axis of symmetry using -b/2a. So -4 divided by 2 times -3. That gives us -4 divided by -6, which is actually 2/3. Okay, so the x value is 2/3. And then the y value would be y equals -3 times 2/3 squared plus 4 times 2/3 minus 1. And so that's going to be -4/3 plus 8/3 minus 1, which is going to be equal to 4/3 minus 3/3, which is equal to 1/3. So our vertex is going to have coordinates 2/3, 1/3. Let's see if we can find the y-intercept. Remember, the y-intercept is always pretty easy. So we'd plug in 0 in for the x's, we get y equals 0 plus 0 minus 1. So the y-intercept is -1. What's the x-intercept? The x-intercept would be the roots of this equation, and we could use the quadratic formula. We've already had a lot of practice with the quadratic formula, so I'm just going to go ahead and do it with a calculator, okay? So I would do apps, or I could just go back to main here. So then I'll go polyroot finder, and then second order, next, sorry about that, next. And then I'm going to put -3 comma, or -3 4 1. -3 4 -1. Okay, and then I solve it, and the two roots are 1 and 1/3. So 1 and 1/3. Okay. And then I'm going to graph this one here. So here is the axes, and then I'm going to have I'm going to divide this up actually into thirds. So each one of these is going to be a unit, 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 unit. Okay. And the vertex is at 2/3, 1/3. So 2/3, 1/3 would be here, right? And then the x-intercepts are going to be 1 and 1/3. So it's going to be 1 and 1/3. And the y-intercept is going to be at -1. So just with this, we can already kind of see what the parabola looks like, right? It's going to be kind of like that. Okay? That's it for that one. Moving on to this one, G. This is a kind of an easier one because you notice that it only has 2 terms here instead of 3. The reason why it only has 2 terms is because there's no c term, right? The c's value is 0. So let's see. We're going to have x, or a equals -1, and we're going to have b equals 6. Let's find the axis of symmetry. It's going to be -6 divided by 2 times -1. So that's equal to 3. So the axis of symmetry is equal to 3. The y coordinate for the vertex, which corresponds to this x coordinate of 3, we can find by putting 3 in for x. So we get 6 times 3 is 18. Minus 3 times 3, which is 9. So the y value is 9. So the vertex is going to be 3, 9. And let's find the y-intercept, because that's always really easy. The y-intercept is equal to 6 times 0 minus 0. Hey, it's 0. Do we think that's weird? Okay, we can think back to our investigation, and actually that's not such a surprise. The last thing we need to find is the x-intercept. And the x-intercept is actually made much easier by the fact that we do not have a c term. When we factor this, all we need to do is factor an x out of 6x and an x out of x squared, and we end up with this. So the two solutions for if we set this equal to 0 to find the x-intercept is 0 and 6. So we already have those now. Let's mark those. So we got x-intercept at 0 and 6. We had the y-intercept at 0, of course, or at not, at 0, of course. The y-intercept is at 0. The x-intercepts are at 6 and 0. The vertex is at 3, 9. So let's put that down. 3, 9. Okay, so here's 1, here's 1, here's 1. Any other points we have? Nope, we don't. So you can see that it's kind of like a upside down parabola, kind of like that, right? Just from the intercepts and the vertex, we can already sketch it pretty well. All right. Last of all, we're going to do I here. And so here we have A value of negative 1/4, B value of 2, C value of C. Let's start with the axis of symmetry. So we're going to put negative B over 2 times A, which is negative 1/4. This is equal to negative 2 divided by negative 1/2, which is equal to 4. Okay? And then the y, this is the axis of symmetry, which is also the x-coordinate of the vertex. And then now we're going to find the y-coordinate of the vertex. It's going to be y equals negative 1/4 times x 4 squared, which is 16, plus 2 times 4, which is 8, plus 1. And we're going to get negative 4 plus 8 plus 1, which is equal to 5. So our vertex coordinate is 4, 5. The y-intercept is going to be y equals 0 plus 0 equals 1, right? So if I put 0 in there, if I put 0 in there, I just end up with y equals 1, so that's the y-intercept. And the x-intercepts are going to be the roots. How do we find the roots? Well, again, I'm just going to use the calculator for this, okay? If you would like to practice your factoring or your quadratic formula, you're welcome to do that. So first I can put negative 1/4, negative 1/4. Then for the second coefficient, I'm going to put 2. And the third coefficient, I'm going to put 1. And then we're going to solve. And we're going to get two terrible looking numbers. Okay, 8.47 and negative 0.472. So I'm going to graph some of these points here. So I'm going to put the axes here, and then I'm going to graph the points for the vertex. It's 4, 5. The y-intercept is 1. The x-intercept is 8.47 and negative 0.471. And so I think with these points, I can already pretty much draw the parabola like that. By the way, it turns out that if you do use the quadratic formula to find the roots here, it's going to be 4 plus or minus square root or 2 square root 5, something like that, okay? Which is the same as 4 plus or minus square root of 20. So that's how you generate these if you use the quadratic formula instead of the calculator.